Welcome, everybody. Thank you to join our session. Today, Shaofeng and I will present our session to see Spark speed up cubing with Apache Spark. So, yeah, we are coming from Kylin. Kylin is a company formed by the creator of Apache Kylin, the team who created that. And my name is Luke Han. I am a creator of Apache Kylin and also VP of Apache Kylin, and also co-founder and CEO of Kylin Inc., which is a startup based in China, and now we are extending business here now. And Shaofeng is also Apache Kylin PMC member, and he is our technical partner and senior architect. Okay, more focusing on the Spark cloud. Okay. So today we will introduce a little bit about Apache Kylin itself, see what it is, and how about the use case. Just highlight one use case. I think it will bring some amazing data to you. And later, Shaofeng will introduce more the technical detail and more focusing on the challenges we faced about using the MapReduce previous and how we replaced that one with Spark, and also the benchmark about that. I think that will be very interesting. Okay. So what is Apache Kylin? So what is Kylin, right? And how pronounce it? So that is actually coming from China, a Chinese legend. We call it a mystical animal, and yeah, many of Eastern people know that. But you could just think about that. This is a unicorn in the Western world, right? So yeah, we hope our company will be a unicorn. So a few years ago, when we are doing research and one trying to build a project, and we pick up this name, there's a lot of animals in the big data zone, right? So we called it Apache Kylin, which we developed inside eBay several years ago. And today, the Kylin itself, we define it as extreme OLAP engine for big data. And today is the #1 OLAP on Hadoop solution. And you can Google it, you will find what it is. And yeah, a lot of use cases I will introduce later. And this is a first born in China Apache top-level project that I think a lot of people you will see that, and also be recognized by InfoWorld a lot of. And yeah, last year we got that best open source big data tool with TensorFlow. Yeah, just about 12 projects. So yeah, just to mention that there are a lot of more than 200 use cases in production all over the world. So you could find use cases from eBay, from Yahoo Japan, from Machine Learning here, from Gatesplay from German, and many of them are coming from China. Most of them are big giants, say Baidu, say NetEase, say Meituan, which is a top 1 O2 company. And then more beyond the internet companies, we already be adopted by most all over the industries, say finance, banking, insurance, securities, and fintechs, and also by telecom. Many of the telecom companies in China already adopted this as their key analytics company platform, and also a lot of from manufacturing, game, advertising, a lot of others. So let me just highlight one use case from China. We call it Toutiao. Toutiao is the top 1 newsfeed application in China, and actually I think it is in the world. Almost every Chinese people are using their app on their iPhone or Android. Everyone, okay. So they are facing a lot of challenges. See, they have collect a lot of data, right? So they'll see 100 billion loads per day, they will generate that. So the challenge is how they can enable their analysts can fast access and analyze that data with their circle technology without programming, right? So that is the challenge they have facing. I will not talk about the detail, but you can come to me later for the detail. But the result is they built an OLAP platform with Apache Kylin, and the result is, say, 1 cube. They call it video impression data. It contains about 3 trillion billion data. That means 3 trillion. And the result is all the circle queries return just less than 1 second. It's exciting, right? And support 1,000 analysts. That means the concurrency is very high. That's very important. But more beyond that, so Apache Kylin brings more, another value is they call that is one build for all queries. Think about it, if you have like 1,000 analysts and run queries every day, your cluster will be a crazy, right, crash every day. Right. So we do that, we build it that and cache somewhere and can serve very high concurrency and high performance OLAP queries for their like reporting, dashboard, machine learning, recommendation, and something else. Okay, I will just stop here and hand over to Shaofeng to talk about the technical part. Thank you.
Thanks, Luke, for the opening. When you see the use cases and the amazing numbers, you must wonder why so many users are starting to use Kylin and how Kylin can be so fast. Firstly, Kylin is a Hadoop native OLAP engine. It acts as the bridge between your BI visualization and your Hadoop cluster. Kylin's backend is a clustered computer, so it can support very massive data process. And on top of Kylin, the query language is standard SQL. That means your users and your applications can migrate to Kylin seamlessly. Kylin integrates with Hadoop cluster very well. It uses the existing component to process your data. For example, it uses HDFS as the storage. It uses Hive for the source system. It uses MapReduce and Spark for the data processing, and use HBase for the online queries. That means if you already have a cluster, then to enable Kylin is a very simple thing. Inside of Kylin, the core concept is OLAP cube. We know cube is a data structure for aggregated result by the dimensions. In the past 20 years, OLAP cube has been widely adopted by the OLAP solutions and the data warehouses because of its extreme fast performance. Now, Kylin enabled the OLAP cube on top of Hadoop. With Kylin, you can create a cube with tens of dimensions and build the cube over millions to trillions rows data. This is almost impossible in the past. Now let's see an example. Here is a typical OLAP query. It simulates an online retail store, which analyzes the returned order status day by day. Such an OLAP query will be translated into an execution plan and will be executed by your OLAP engines. Well, here we see the table joins, the aggregations are not inclined to change. Their patterns are relatively fixed. So why not we using an offline cubing job to process the data into a OLAP cube? Then with this cube, the query can directly start from the cube. With the index for the dimensions, the filtering can be very efficient. And we assume most of the calculations has already been done in the offline space, so the data for post-aggregation can be very minor. So all the left steps can be totally happened in memory and in a very high performance way. This explains why Kylin can be so fast. And look at the cube. Actually, the cube size is determined by the cardinality of your dimensions instead of by your source data. Then we see Kylin is an OLAP cube whose time complexity is close to 0.1, while other engines, they don't have pre-calculation. Their time complexity are some sort of ON. The 0.1 time complexity means it can provide a consistent user experience as your data, as your business grows. And the more data you have, the more frequent you analyze the data, the more benefit you can get from Kylin. To verify this, we did a test with the star schema benchmark. We collected the query performance at 3 data scales, 10 million, 20 million, and 40 million rows. Look at the first chart. For each query, its performance is almost the same at the 3 data scales. And we can see all the queries can be finished in less than 1 second. Compared to Hive need much more time because it doesn't have cube. And its response time gets increased as the data grows. So this verified the assumption we made on the previous page.
The same schema and same amount of data in Hive and Kylin.
Yes, yes. For more information, you can check out this GitHub project. We publish the data model and the test result there. This is the architecture of Apache Kylin. Kylin fully leverages the existing components on your Hadoop. The left side is the source system. Kylin supports Apache Hive for the batch data, Apache Kafka for streaming data. It can incrementally load the new data from the source system and stage it on HDFS. Nextly, Kylin will start in parallel processing jobs within MapReduce or Spark to process the source data into the cube. The cube will be converted to HBase format and backloaded to HBase cluster. Then you can send your SQL queries via Kylin's ODBC, JDBC, or RESTful API. Kylin will pass your SQL queries and then translate to the cube visitings in HBase. As we know, HBase is a data store which provides by raw key, random scan, and very low latency. So with the aggregated result in HBase, we ensure that the query can be finished in a very low latency. And during the runtime, Kylin will not touch your source data because its performance is out of control. Now, here we see the cube build is the most time-consuming steps. Although it's an offline step, which means it doesn't impact your online queries, while many community users still wish to speed up the cube build. Today we will focus on how the cube will be built. Now let's see a sample. Here I have a small table which only have 4 rows, and now I want to build a cube with 3 dimensions. 3 dimensions will generate 8 dimension combinations, what we call as cubeboard. Then for each line, each row source data, it can map to 8 cubeboard rows. By shuffling and grouping the same dimension values together, and then we can sum up the matrix values, finally get the cube be built. So the cubing process is a typical map, shuffle, and reduce process. While in the real world, we will not do in such a simple way because it will generate too much intermediate data. For example, if you have a cube which needs 10 dimensions, then it can have more than 1,000 dimension combinations. If each line maps to 1,000 cubeboards, then it's a huge data. We need a way to do it step by step. This is the default cubing algorithm in Apache Kylin. We use a bilayered cubing method to process it. Here, the original data is the source data. With the first round MapReduce, we will calculate the base cubeboard, which is the combination of all dimensions. Then based on the base cubeboard, we start start second round MapReduce to calculate the n-1 dimension cuboids. And so forth with n+1 round of MapReduce, finally we get all the cuboids be calculated. This method is very stable. Most of the users are using, almost all the users are using this way to process your data. It works for million, billion, and even trillion rows data. Well, we still see many challenges here. The first challenge is the performance about the data sharing. As we know, MapReduce uses HDFS as the file input and the file output. So to share the data to the next round MapReduce, we need persistent the data to HDFS. It involves much serialization, data replication, and deserialization. The second challenge is the repeated job submission. Think about if your cube has 20 dimensions, then you need 21 rounds of MapReduce. If your cluster is busy, then each submission will involve many job scheduling overheads. In the total, you have a long time to wait before the cube be built. The other challenges include MapReduce doesn't have native support for streaming data. So to enable the source data from Kafka, we have to stage the data from Kafka to HDFS before processing. On the cloud deployments, today we have many different storage systems such as AWS, S3, Kinesis, Elasticsearch, etc. While with MapReduce, we couldn't native to support these systems. So to overcome these challenges, we were thinking different ways. If you are an early user of Apache Kylin, you might have heard of we introduced MapReduce in memcubing method in Kylin 1.2 or 1.3. At that moment, we tried to optimize the method on MapReduce to overcome the first two challenges, but the result isn't that good. I will share some performance data later. Finally, we decided to try Apache Spark. I believe every one of you knows Spark very well, so I don't need to introduce it in detail. In the development for Kylin 2.0, we moved the cubing jobs onto Spark. The methodology is similar as what we did in MapReduce. We use the bilayered cubing method. Here we abstract each layer of cuboids as one RDD and use parent RDD to generate the child RDD. If we cache the parent RDD in memory, then we don't need to read up them from disk. When child RDD gets calculated, the parent RDD can be exported to Hadoop as files and then removed from the cache. Spark provides the Java API for you can easily migrate from MapReduce to Spark. So we can reuse most of the aggregation codes that we development in Kylin. This is the DAG when Kylin built a third layer cuboids. Since the parent RDD already be cached, so the stages from the original data source can be directly skipped. And the Spark is fault tolerant. If one node is failed and your RDD is incomplete, then it can smartly rebuild the RDD from the source. In one Spark application, you can do as many rounds of aggregations. So for Kylin, we don't need repeated to start the jobs. We can do all the layers aggregation in one Spark. We did a performance benchmark between the MapReduce engine and the Spark engine. The test is performed on a 4-node Hadoop cluster with the airline data from US Department of Transportation. The cube has 10 dimensions and 5 measures. We tested the build performance at diff 3 datasets. The first dataset is 3 million, which is very small. Here we see the Spark only need about half time of MapReduce, and when the data is in the medium size, it is almost about 40% of the MapReduce. And as the data grows, which is the full dataset, 160 million rows, the memory on this Spark class wasn't able to cache all the intermediate RDD, so it spilled some data to disk. This caused the performance a little decrease. Well, even so, it is still be 40% faster than MapReduce. As I mentioned, we have tried imam cubing with the MapReduce framework. The core idea in the MR imam cubing is to allocate much memory to each mapper, and in mapper side do as much as aggregations within the memory. Finally, with one round shuffle and reduce, get all the cuboids be generated. Well, from our experimental, MR imam cubing is very picky on the data distribution. If the data size is big and the data is random distributed, that means the mapper side couldn't do much aggregation. So many calculations need to be happened in the reduce phase. So its performance is even better than the bilayer cubing. Well, if we let the source data be distributed by a high catenarity dimension, the MapReduce imam cubing can be very fast. Well, for both the data, random distributed or well distributed, Spark cubing is very stable and its performance is very close to the best performance of MapReduce imam cubing. So we see Spark cubing with a layered algorithm is the best choice here for Apache Kylin. Now, let me do a quick summary about our experimental by moving the cubing to Spark. Firstly, Spark can speed up the cubing with at least one time. The test is based on Spark 1.6. We believe there are rooms to improve when we upgrade to Spark version 2. And with Spark, the development for big data processing is much easier than before. You can do more functions with much less code. And Spark has a very active community and a very good ecosystem. By integrating with Apache Spark, we can support more scenarios and more environments. For example, we can move the streaming cubing to Spark streaming to support the real-time OLAP. We can integrate with Spark SQL as a new data source or an engine for the ad hoc queries. And integrate with Spark, we can support more cloud storage systems. this is all about our experience in Apache Kylin 2.0. Thanks for listening.
So wait a moment, or we need a microphone.
Sorry about that. Any comparison between Druid and Kylin?
Okay, before Druid and Kylin, right? Okay, both Druid and Kylin are OLAP engines, I think, right? I don't have much experience with Druid, but I think they have something in common and have some differences.
Yeah, I think Druid more focusing on the real-time ingestion and analytics side, and Apache Kylin is more focusing from the OLAP side. So it is more for the analyst. So and you can check from our mailing list. There are some like discussion about that. Yeah.
Yeah.
Hi, my name is Deb. So I saw that the tech you showed the Tableau icon in the UI web app. So my question is like that when you have like terabyte size of data in the cube, so doesn't the UI face any issue to hold that data in memory? Like when you run some queries from your UI app. So how Kylin help in those kind of situation to pass that data to UI?
Okay, so let me try to answer this question. So question is, seeing we are using Tableau as our front end and see if there are a lot of data, how we can handle that, right?
Yes.
So yeah, that is actually is a sweet part between to leverage both Tableau and Kylin. So think about if you have like 3 trillion data, it is not possible to put that data into your Tableau extract, right?
Yes.
And even or to any other like in-memory system, right? So the Kylin is we generated to be a disk bundle system, and when the query coming from like Tableau, we using just a live connector to the Kylin source. The live connector is very important. We do not pull the data from source to a Tableau side. So it will push the circle to a Kylin side and just get the result, the aggregated result. So think about it, if you have like a billions data, but your result is actually maybe just like 1,000 or even like a few rows. Right? That is why Kylin is very fast.
So what is this live connector? That runs on a cluster, or how do you do scaling on the live connector?
Excuse me, could you repeat?
I mean, how do you do scaling on the live connector? Like the live connector you mentioned about Kylin and Tableau. So does that connector need some cluster or distribution system to run on, or it just run on Spark?
So yeah, you just need to deploy like Kylin beside like your Hadoop cluster, and Kylin provide like ODBC driver and JDBC driver like a REST API, so you can connect this. So think about Kylin is a client application between your Tableau and your cluster, and it can help you to handle all the like distributed data.
Okay.
Yeah.
Thank you.
Okay. So over there.
So one question is, I have a couple questions. One is about deployment. Is it possible to use without HBase or use a different format?
About HBase.
Who is asking? Oh, can you repeat? Sorry.
Yes, I'm asking if it's possible to deploy using a different format than HBase.
So yeah, actually we did. So yeah, open source Apache Kylin, we're using HBase as our storage, and from our enterprise version, we totally replaced that one with our own column storage just on top of HDFS. So it's possible to leverage any like a KV value system, but today we have an interface over there, but we do not implement too much. It depends on community needs. Yeah.
Okay. And my second question is if you can give us a sense of the time it takes to build a cube, like in terms of the pipeline.
How long to build a cube?
How long to build a usually build a cube takes tens of minutes to a couple hours. I can give some example. For example, we have a telecom user. They have 20 billion raws data to process daily. And in their cluster, the cube build takes about 2 hours. Yeah, this is just for a reference because different cube has different characteristics.
Right. Thank you.
Thank you.
Yeah, so one question on the cube-ROI. So you mentioned that it's taking all the possible combinations. So in the HBase, when you store the data, does it actually store in all the combinations, or is there some optimization that you've done to collapse the data?
Sorry?
Okay, so you mentioned, say, your dimensions, right? So you would store all the possible combinations of the dimensions? Is there any optimization that you've done?
Yeah. By default, Kylin will calculate a full cube, which means all the combinations. But you can customize this with some rules. For example, you can specify some dimensions are a hierarchy. Then Kylin can prolong the combinations which doesn't follow this hierarchy structure. And you can specify some other advanced features to further optimize the combinations. Then you can reduce the calculations and reduce the storages. Yeah.
Okay. My second question is on, excuse me, with the streaming with Kafka. Is there any restrictions on how the batch size is going to be? In terms of how much data it needs to be batched before it gets into Kylin?
For the streaming case, Kylin uses Kafka as a source system, while the processing is happened on the Hadoop cluster. So it can handle from small data set to a very big data set. About the build incremental, it's totally determined by your need. You can trigger the build every, for example, couple of minutes, and you can trigger that.
You can introduce our demo with Twitter.
Yes.
I think just the highlight is good. Don't let that.
Okay.
Don't do the live demo.
We have an online live demo with Twitter data that incrementally built into the cube. It's on our Kylin's website.
Yeah,
we can talk offline.
Yeah, it runs a bench job about like 5 minutes.
5 minutes.
And that application is run on Databricks over like half a year.
More than half a year.
More than half a year.
Almost
Never done.
1 year.
And the performance is very promising. So you can try to hub.kylins.io and you can check that.
Okay, thank you.
Thank you.
Thank you.
So time that, if you have more questions, I think we can discuss offline. Thank you very much.
Thank you.